Hello, we are actually live.
We did it.
We did do it, yes.
How's it going?
It is a rainy, gross day here. We have the rain that I think you would so desperately like. My hair is still wet. Like, my hair is never going to dry out ever again. It's
Yeah,
that kind of a
yeah,
wet, gross day.
yeah. It's just like the snow, like on the west coast here of Canada. We're very used to working outside, building, doing stuff in the rain. The
Yeah.
snow, though, not so much because it's this horrible, gloopy, wet snow, and so it's going to cause some delays with the construction if we can't get it cleared out and plowed. So yeah, we should be getting rain as well, which would be nice. Really help get everything all kind of cleared up. Um, okay, so this is going to be the
I need to open
penultimate
my
show.
audio. Yes.
We're going to do a show next week. We'll do sort of
Mm-hmm.
a holiday wrap up. What last minute presents? What are we looking forward to in the future, etc.
Yep.
Which sounds good. And then we'll be off for 2 weeks, and then we'll be back.
And
The
we're
Expanse
coming
comes out today.
back. We're coming back just in time to get one show in before we're hit by AAS.
Are you going to be covering? Are you going to AAS?
I was supposed to, but it's just too high a risk. I
Yeah,
canceled.
yeah, yeah.
I was even supposed to be giving an invited talk, and for me it's a double whammy because I'm like really allergic to latex, which is normally not an issue, but this means I'm allergic to latex gloves and the elastic on every random stranger's mask.
Right.
And I'm allergic to citrus, which is in a whole lot of the cleaning solution they use. And so I have this fear that I'm going to show up and they're going to be doing everything right and they're going to be cleaning surfaces and
Right.
wearing PPE and it's
And you're going
going
to be
to
covered in hives.
or stop breathing.
Okay.
And
Ew.
yeah, so like if I use an EpiPen, it's okay, you go to the ER now. And then if the ER is filled with COVID, so it's
Yeah.
like I could die by PPE,
Yeah.
which is just not a joyful thought.
No. 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 The die by the stuff that's trying to protect everyone. No, not a
Yeah,
good plan. Yeah. So Nicholas B is mentioning to the Expanse. The final season of the Expanse is happening now.
yeah.
Woo!
I'm gonna binge watch this weekend while assembling furniture
Well,
and
they're
stuff.
only doing one. Oh, unless you have to catch up, but they're only going to do
I'm
one
gonna
per.
catch up. Yeah, I'm
Yeah.
gonna
Yeah.
rewatch the last season.
Yep. Yeah. Carla just rewatched them all, and she finished the last book. So she can't wait to see how they deal with it in the series. But I haven't read any of the books. So
I
um,
like the TV
okay.
show better the further in the past the reading of the books is. We discussed this last week. It's like you and Foundation.
Yeah. 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 Yeah.
This
No,
is
I'm definitely a
624.
curmudgeon about an adaptation of that. This is 624. Yes.
Okay.
I just watched Hellbound on Netflix.
How is it?
Really good.
Okay.
Really good. Yeah, it's a Korean, I'm such a fan of
Yeah.
Korean TV and movies. And so this is by the same director that did Train to Busan.
Oh,
And 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 so Train to Busan was a zombie movie, but it told a much deeper story about
yeah.
about sacrifice. And this show, Hellbound, is is really unsettling, and you won't believe what you're rooting for. And and it's yeah, it's really good. It's really
Ah,
good, but it's very um it tells a very interesting kind of view on the interaction, like essentially kind of like cult conspiracy theories sort of interacting about in people's lives. And yeah, it's great. It's great. Great show. I highly recommend it. Very uncomfortable, but also wildly entertaining. So
I'm reading a
keep
book
keep
like
giving
that.
these hits, Korea. I love it.
Yeah,
Yeah.
I'm reading Krampus by Brahm right now, and it is dark. It's super dark, but it's beautifully written. And
Yeah.
I'm reading it on stream because there's permission to read a lot of copyrighted books right now because of COVID.
Yeah.
And everyone's like, "Oh, that hurt. That is not Christmas, but it's set at Christmas, and it's a Christmas
Right.
book, but it's dark and it's good, and
Isn't there
like
a movie
all the
based on
mixed
it
emotions."
as well?
Not on this. There's a whole lot of different books named Krampus,
Okay. Okay.
not
Okay.
this
Okay.
particular
Right.
one.
Okay. Okay. All right. Let's get cracking. You ready?
I am pressing record, and it is recording.
All right. I have also pressed record. Here we go. Astronomy Cast, episode 624, Small Rocky Bodies. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. It is rainy and cold, but that is superior to so many ways of the weather could be right now.
Yeah. Yeah. It's funny how as the weather turns and you're like, oh, I just wish it was warm and rainy. And then later on, you're like, I wish it was at least cold and rainy, but not wet snow. So yeah, every time as the weather turns in the winter here, you just like, you long for the previous month's weather until we get around to spring.
And the irony we have here, and there's science in this, I promise, is it's the super sunny, crystal clear winter days that are the worst, because that layer of clouds is thermal insulation.
Yes.
So on a super cloudy day, it's only going to get so cold because the infrared radiation is bouncing around between the ground and the clouds. But those crystal clear days are brutally cold, and those are the days I sit in a sunbeam and wish my windows were better.
Yeah, we have the same situation where when it's clear and sunny is when it's the coldest for sure. All right, so we've talked about icy objects of the solar system. Today, let's talk about space rocks. There's a surprising variety of rocky material in the solar system, and each object has a story to tell about the history and formation of the planets, moons, and the other rocky bodies. All right, we'll get to that in a second, but it's time for a break. And we're back. All right, Pamela, you queued up this topic. Where do you want to go today?
Well, so we talked about the massive objects that are differentiated and could be called worlds. So I think today is a good day to look at the weird small stuff that you can still call a world, because really you can call anything in space a world except for man-made objects. And then you can try. I would just argue with that one.
Not yet. Yeah, megastructures. We're not there yet.
Right.
But like last week we talked about the near-Earth objects, the asteroids, the potential planet killers, or the bad day makers.
Yeah.
But today we're going to talk about larger objects. So give me some examples of some of the kinds of objects that you would classify as small rocky bodies.
So you have the classic sort of Phobos and Deimos, these two potato-shaped moons of Mars. You have Ida and Dactyl and Eros and Lucia and Itakawa and Ryugu and Bennu, and basically all of these objects that are at most 100 kilometers on one side, but probably tens of kilometers on another, and are anything but round if you take a good look at their shape.
So that not roundness,
yes,
where is that coming from?
So as objects get bigger and bigger and bigger, once they go past a certain crossover in size, gravity is able to basically say, nope, that hill, we're going to squish it down. Nope, that hill, we're going to squish that one down too. And gravity is responsible for making things round. The smaller the object, the bigger the mountain you can have, but overall, you're going to end up with a round object once you're big enough. Now, if you're small, gravity may not be the dominant thing holding you together in all cases. Gravity is there, but you also have to look at electrostatic forces. The forces that cause the molecules and the minerals to bond and build. A rock out by your driveway isn't held together by gravity. And an asteroid is a lot more like that driveway rock than the asteroid series.
And we're here on the surface of the Earth, and from our perspective, you see a lot of hills and mountains and depressions and valleys and all kinds of landforms. But if you zoom way out and look at it from, say, the surface of the moon, then the Earth looks like a perfect sphere. And for all intents and purposes, it actually is very spherical, although it's an oblate spheroid. But still, it's a very smooth sphere from the large scale when you consider the entire size of the Earth. And that's gravity pulling it all together.
A slightly flattened basketball with the texture of a basketball would be far lumpier if scaled up to the size of the Earth than the Earth actually is. And
that's amazing.
That's just something that gets me every time.
Like a basketball would have bigger mountains than the Earth does.
A basketball is,
That's incredible. So we've got these smaller objects there. They don't have enough gravity to pull themselves into a sphere, and so they can be kind of any shape. Where do they come from?
They have a bunch of different formation mechanisms. On one hand, some of them are just things that failed to get much larger in the early formation of the solar system. Some dust hit some dust, they got together, they pulled in some more dust, and they stopped. And so you can end up with these chemically pristine rocks that are weathered by sunlight on the outside, but otherwise are just pure representations of what our early solar system was made of. Mm-hmm. In other cases, you also end up with objects that were shattered. There's some thinking that metallic asteroids actually come from originally larger objects that got hit, had the earthy parts knocked off the outer shell, leaving behind just this metallic core. And then, of course, you have things that are the leftovers of massive collisions that just left rocks. It's thought that Ryugu could be the remains of multiple objects that smashed one another to smithereens.
Yeah. It's interesting, like Vesta, for example, which is one of the largest asteroids in the asteroid belt and one of the targets of the Dawn mission. Their astronomers have traced a bunch of objects which are probably in a similar class as Vesta. And in fact, many of the meteorites that have been found on Earth that come from another world have come from Vesta. And so at some point, Vesta got smacked hard, and debris is making its way out into the solar system. And I guess you can imagine. So there's like forces pulling these larger objects apart, but also forces bringing these smaller objects together.
And this is where we live in a dynamic and evolving solar system. And what we see today tells us that in the past, things were exceedingly more violent. And asteroids have really fascinating ways of holding on to that history. One of my favorite examples is an asteroid that is doing its best to resemble a moon, and this is Deimos. And Deimos is, Phobos. And Phobos has these amazing cracks all along its surface that were originally thought to have been caused, by something smacking.
Speaking of things smacking.
I don't know what just happened, but a rain of plaster dust just came down.
It's probably fine.
It's probably fine.
I can't imagine a rain of plaster dust inside your house would be a cause of concern. Carry on. Be a professional. We record.
All right. Yeah. Going back to the beginning of that idea.
Phobos.
I'm actually going to talk about a little asteroid that's doing a really good job of masquerading as a moon, and that is the moon Phobos. Phobos has a series of cracks that were originally thought to be related to a massive crater that's on its leading edge. As it goes around, it's tidally locked, so that crater is basically like a bulldozer scoop in front of it. But it's not perfectly lined up in the path that this little moon is taking around Mars. And it turns out that these cracks aren't aligned with the crater. They're aligned with the orbit, and it's thought that on a regular basis, as massive objects hit Mars, create massive new craters, chunks of Mars will get sent up at escape velocities, or at least velocities that put them in orbit, and this little moon plows into that, and those objects form these cracks along its surface.
I mean, the actual source of Phobos is a bit of a controversy, isn't it?
Yeah.
Like where it came from.
There are those who believe it is a captured asteroid, and there are those who believe that just like our moon, it was created through some sort of an impact event. And then making things even more interesting is with the moons of Mars, the inner one is actually working its way around Mars faster than Mars is rotating, and that inner one is Phobos, which is much more boring looking. And as Phobos gets closer and closer and closer, it's eventually going to tidally tear itself apart. And the reason it gets closer while our own moon moves outwards is that fact that it's going around faster than Mars is rotating. So angular momentum does bad things. If you orbit too fast, if you orbit faster than a world is rotating, you move inward. These are the rules. And looking at Deimos as something that will eventually shred itself, there's this notion. That's
Phobos
what
is going to shred itself. You said Deimos.
I thought Deimos was the inner one.
No, Phobos is the inner one.
Phobos.
Deimos is the outer one.
Thank you. I lied. I'm going back to the beginning of that thought too. I cannot keep these two moons straight to save my life, clearly.
Phobos is the big one.
Yes.
Orbit's close. Deimos is the small one. Orbit's farther. Phobos is going to crash. Deimos won't.
I can keep their sizes straight, just not their order of operations. So over time, Phobos is going to migrate inwards. There's this weird thing with physics where if you go around a world faster than that world is rotating, your orbit moves inward. This is the opposite of what we see with our own moon, where as it goes around, we're rotating much faster, so it's able to move outward. With Phobos moving inwards, this gets folks thinking that maybe these could be rocks that regenerate themselves by migrating where they don't belong, shattering, and then coming back together, and perhaps mass has been lost over the time. There's crazy computer simulations showing how this can be possible in special circumstances. Wow. I'm not sure we're ever going to know how these moons formed, but we're going to do the best we can to figure this out. There's actually a Japanese mission on its way to go check out these moons. And you probably know more about this mission than I do.
Yeah. The Japanese JAXA's MMX Phobos mission, and it's going to visit at least Phobos, maybe Deimos as well, and possibly drop landers and hoppers and things similar to what happened with what happened with Ryugu.
2.
Yeah, with Hayabusa 2 and Ryugu, and the hope is, and maybe even like drill a sample a little bit under the surface. And the goal is to try to answer once and for all, was Phobos and Deimos broken off from Mars through some enormous impact in the past, or were they captured asteroids? But I think, my reading right now, the consensus is definitely leaning towards that they are shrapnel from a giant impact in the past. And we will talk about another object, but it's time for another break. And we're back. All right, enough time spent on Phobos. Let's think of another characteristic example of a small rocky body that that fits the bill. What else do you want to talk about?
Well, we have Ryugu, Bennu, and all the other rubble pile asteroids that are out there, and there's a whole lot of those. And
so, I mean, we saw like Itakawa, which
yeah,
was the asteroid that was visited by the first Hayabusa mission,
the great
and it was
cashew.
yeah, and so it was clearly more like a rock, less like a
Yeah.
rubble pile. But then we see with Ryugu and Bennu, these things are rotating 10-sided dice. They're rubble piles. So what's the cause of these?
Some objects are less lucky than others, is the best way to put it. In a universe that may be mostly empty, things still find a way to collide. And the degree to which this happens is something that we're only now, I think, really coming to fully appreciate. Once upon a time, we taught people, no, stars never collide. No, stars do collide, folks. They do collide. We used to say the asteroid belt is so empty that collisions between asteroids are rare. And now we go looking at Ryugu with Hayabusa 2 and discover there's bits of Vesta in there, there's bits of regular chondroid in there. It is a mess of stuff from at least 3 different sources. Bennu, we're
Vesta
still working.
Really got around.
Yeah. And so you can just imagine 2 rocks minding their own business, and they're just on intersecting orbits. And these intersecting orbits cause them to collide and form a cloud of debris. And that cloud, gravitationally, everything is acting on the center of mass, and it's going to collapse in on that center of mass. And apparently end up shaped like an 8-sided, 10-sided, or 20-sided dice, depending on your opinion.
Right. 10-sided. That's the right one. That's what they look like. Yeah, and so, do we have a sense? The fact that we've seen 2 of these now, do we have a sense of how much of the solar system are made up of these guys?
So we've only seen 2 in high enough resolution to confirm that, yes, these things are essentially giant ball pits where some of the balls just happen to be boulder-sized. But we have observations of enough other objects to understand there are actually a lot of things that are either 2 giant pieces held together by a bridge of debris, that there are things that are collections of larger rocks. There's a lot of things now that we're willing to say this is a rubble pile. So in terms of exactly how many, we're not there yet. But my feeling is that it's probably going to be at least 10%. This is a gut feeling based on current observations. I couldn't find a paper to answer this question for me. I did try. But the more we look, the more of these things we find. It's just luckily there are the metal ones out there going, hi, we're 40% and we aren't rubble.
Right. So. All right. Well, we're gonna talk about some other objects in a second, but it's time for another break. And we're back. All right. So we've talked about like asteroids posing as moons, or maybe not. Asteroids smashing into each other and turning into just piles of rubble. What other kinds of rocky objects would you find in a survey of the solar system?
Well, there's in general, you have the ones that are M-type. Those are the ones that have nickel iron cores, and may, it turns out, have a volcanically formed crust. That's
what?
Yeah. So I in prepping for this episode, came across a 2019 paper where they talked about the problem with how asteroids cool. So if you start out with a asteroid that is big enough that it has started to differentiate, so you have a earthy carbonaceous chondroidy crust around a nickel iron core, the outer part will solidify first, leaving you with a still squishy molten iron
Hmm.
nickel core. Now, if something comes along and smashes that and causes the earthy parts to get knocked off, that crust to get knocked off, leaving behind the higher density nickel iron, well, you've just added more energy, you've added more heat into the system. So you still probably have a mushy gushy nickel iron core, and that's going to harden on the outside first. But you've now trapped the heat on the inside.
Yeah.
And it's going to want to escape because that's what heat does. And so the idea is that it's possible that when the mission gets to Psyche, it's going to find evidence of past volcanoes where it was basically molten metal erupting up out of these volcanoes. And that's just a lovely idea in a
Yeah.
very dark and twisted, where's the Magic the Gathering card for this kind of way.
Or metal volcanoes.
Yeah. So we will
Yeah.
have cryovolcanoes. We will have iron volcanoes. It's awesome.
And the regular rock volcanoes that we're so familiar with today.
Yes.
And so, one mission that is on its way now, NASA's DART mission has launched. And we talked about it a bit last week. But do we know anything about the targets, about Didymus and Didymoon?
So they appear to
how
be
these
solid.
compare?
So these are small rocky objects. They appear to be solid objects so far, but our images of them aren't that great. These aren't objects that are large enough, as far as we understand, to be segregated out into different layers, to be differentiated. It's basically a rock and a smaller rock.
Right. And I guess we're going to find out if DART slam into the surface of Didymoon, or will it punch a hole through and create a cloud that will then reform?
And the concern, as I mentioned last week, is the moon could be something that was knocked off instead of captured by the larger object, the parent object. And knocked off stuff could either be rubble or just a chunk knocked off. So we won't know until we hit it or see it. We'll know to a degree when we see it.
But that's the whole point.
Yeah.
That's the whole point of this mission is to whack into it and learn what happens. Not have any assumptions. We'll find out through experiment, and chances are it'll shatter all of our experiments. It'll shatter all of our assumptions about what's going to happen. So, I mean, with the number of asteroids that are currently in the solar system, are there significantly less today than there were back in the early history of the solar system?
I'm not sure I would say that there's significantly less. There are so many, but in the past you had more larger objects that have now knocked themselves into smaller objects. There are chunks of Vesta out there. There are entire families out in the asteroid belt where we can go, this section of asteroids all has the same chemical properties and probably came from one object. There's a whole section over here have the same chemistry, probably came from the same parent object. So yes, asteroids are striking planets, striking moons, striking things and ceasing to exist, but they're also striking each other and reproducing by breaking into many different pieces.
Right. So you're getting more but smaller pieces as they continue to crash into each other. Yeah. And I mean, Jupiter, it's interesting. Like I did a bunch of research into this as well, just that Jupiter is constantly shoving asteroids out there's a constant train of asteroids leaving the asteroid belt and making their way into the near Earth object realm, that they are a renewable resource. You could remove all the asteroids that were potentially dangerous to the Earth, give Jupiter a few hundred years, and it will have more lined up for us.
And Jupiter's an equal opportunity rock thrower, as a lot of models done by one of our friends, Kevin Grazier, has shown. It is perfectly capable of flinging things inwards and outwards. And so we also get to watch as Some of the Trojan objects migrate in as the centaurs. Centaurs are not stable. They are going to migrate in. Yeah, it's kind of awesome.
Yeah. Very cool. Well, it's kind of hard in one episode to give a survey of what could be hundreds, thousands of different examples of these kinds of objects, but it's nice to sort of get a high level survey. So thank you, Pamela.
My pleasure.
All right, do you have some names for us?
I need to open that file. Some weeks I am better prepared than others. There. Move this closer to the camera. Sorry, editors. Sorry, Rich. Sorry, Allie. All right, I've now covered Fraser in names. We are, I'm going to give you a pause. We are, as always, here thanks to the generous contributions of folks like you. It is our community over on patreon.com/astronomycast that makes it possible for us to have Allie and Rich out there for me to constantly apologize to as I make mistakes in these episodes. It's what allows us to have Nancy Graziano running herd over the two of us cats, and, well, Beth Johnson out there promoting us on social media. You give these people jobs, keep us sane, and allow this show to happen. This week, I would like to thank Bruce Amazine, Ninja Nick, Arthur Latz Hall, Thomas Sepstrup, Mountain Goat, Burry Gowen, Jordan Young, Stephen Veit, Kevin Lyle, Jeanette Wink, Andrew Poelstra, Venkatesh Chary, Brian Cagle, David Truog, TheGiantNothing, Aurora Lipper, John Hook, David, Gerhard Schwarzer, Will Hamilton, Ronald McCoy, Jean-Francois Ragette, Kako Seraph, Bill Hamilton, Robert Plasma, Laura Kittleson, Jack Mudge, Joshua Pearson, Les Howard, Joe Holstein, Sean Matz, Gordon Dewis, Frank Tippin, Alexis Neuter Dude, Helga Bjorkhog, Adam Annis Brown, Ben Lieberman, William Backer, Wanderer M101, William Andrews, Jeff Collins, Travis Dalziel, Harold Baggerhagen, Nikki Lynch, Marco Iarasi, David Gates, Randa, Brian P. Cox, Matthew Hortzman, Philip Walker. Thank you all. Thank you for making what we do possible.
Thank you, everyone. And we'll see you next week. All right. And then they saved.
Yes.
$624.
I think I just saved that in the wrong directory. Yep, I did. All right, let's save it in the correct directory. All right.
I've done the same. Okay, I'm uploading.
Okay.
Awesome. All right, hit us with your questions. Arjone, do the large planets make it too hard for the asteroids to make larger bodies?
Say that again?
Do the large planets make it too hard for the asteroids to make larger bodies?
Insofar as they clear out their orbits, that thing the IAU came up with, having something with a big mass around is going to eat up all the mass around it. So, yes, but
yeah, and
space
Jupiter,
is big.
Sure, but Jupiter, for example, definitely perturbs the asteroid belt and prevents them from collecting into any one object.
Yeah,
although
that's true.
the stat
There's
that I always
not
love to
enough
talk
mass.
about is the stat I always love to talk about is that if you took all the asteroids in the asteroid belt and mashed them into one object, you'd have 5% the mass of the moon. So it would not be very interesting. It would not be a planet.
Yeah. So Kangaroo Steve over in Twitch asks, do they know how long it will take Phobos to break up? I've seen calculations and I don't remember the numbers, but
50
I
million
know.
years.
Okay, Fraser knows these numbers. I do not know numbers.
Yeah, 50 million years-ish. So anywhere between kind of 10 and 100 million years is how long it's going to last. Quadlibit asks, how much of a hazard do these rocky bodies pose for future space travel?
Not really any. We have to aim for them.
Yeah. Yeah. That whole idea of like passing through an asteroid belt and you're just going through this clustered sky filled of tumbling space rocks is not the case.
I'm rereading 2001: A Space Odyssey and realizing Hal is in way less of the book than I remembered. But beyond that, there's this whole bit where like the astronauts get one day of excitement on their way out because they encounter an object. Just one. That's it. They encounter it, then Jupiter, and then Saturn.
Yeah, that's funny. Let's see.
Broken Symmetry writes, go ahead and buy that condo on Phobos. There's actually been talk of building a basically relay point on Phobos. So you go from Mars to Phobos, Phobos to the rest of the solar system.
Yeah, it's a great idea actually, because the thinking is that trying to land heavy payloads on the surface of Mars is actually really complicated, and NASA hasn't figured out a way to land beyond about 3 tons to the surface of Mars. Now, Elon Musk and SpaceX are planning to land starships there, but who knows if this technology is even going to work. And so the idea is that you set up a way station on Phobos where you fly to Phobos, land on Phobos. There's a base on Phobos. You refuel your lander, and then you've got lots of fuel to make a propulsive landing down on the surface of Mars. So there's a lot of really good ideas how you could use Phobos. You could drill into it and live underground on Phobos. It's a pretty great place.
Yeah.
It's a real gift. Don't look it in the mouth.
You should always look a gift horse in the mouth, though. I made that mistake once. I'll never make it again.
Yeah, but that's a free horse.
Yeah, but if you don't look in their mouth first, those dental bills may cost more than a horse.
Ah, interesting. Okay. So Arjun asks, did they ever figure out how Arakoth formed so far away from the sun? So interesting that 2 objects could find each other out there.
So that's MU69 is its other name. It's one of the objects. It looks like a red snowman. It was encountered by the New Horizons mission, I want to say a couple of years ago now, many years ago now.
Yeah, not many, or maybe 2 years after the flyby.
It was in the before COVID times.
I guess so, yeah. Time does have no meaning beyond a certain point.
It's Blur's Day forever.
Yeah. It's Happy Blur's Day.
So, yeah, that object was exceedingly difficult to find, but we're still trying to figure out how much stuff is out at that distance. What we're finding is a lot of it is super red and hard to see and icy, so it's cold and hard to detect. And all of this adds up to a whole lot of question marks. We know that there's debris all the way out to the Kuiper Belt itself extends to, I believe, 1,000 astronomical units. And Arakoth is, I want to say, out at like 10 AU?
Well, no, like it's way beyond the orbit of Pluto. Pluto's like 30 AU. So
okay, sorry, I'm having a
so it's in like probably in the
numbers.
40s. I can get the exact. I'll get the exact orbital of Arakoth.
Never trust me with specific numbers.
What is its perihelion? 46 is its aphelion, and 42. So its semi-major axis is 44. That's pretty close. Okay.
Yeah. So there's a bunch of stuff out at that kind of distance. It's just that's such a huge volume that it could be 10 times as much stuff as what's in the asteroid belt and still be emptier than the asteroid belt. And it's just harder to find stuff at that distance.
One of the objects that Lucy is going to be visiting as part of its mission is similar in composition. These red Kuiper belt object types. So the interesting thing about the Trojans, Jupiter's Trojan belt, is it's a random collection of stuff from the inner solar system and the outer solar system, and it's part of its mission. Lucy's going to go past a bunch that are very similar to Itokawa or Eros. Probably some are going to be rubble piles, but at least one is similar to one of these reddish Kuiper belt objects, which is pretty exciting to get one this close that you're going to be able to do this great flyby, which was intended the whole way. So Visututi then asks, but if not for Jupiter and its rock throwing, could the asteroids have formed another planet? So if Jupiter wasn't there, would you get another planet?
Tell us the total mass of the asteroid belt compared to the moon.
5%.
Yeah, there's just not enough mass out there.
So you would end up with a super series.
But the issue starts to become that the material is initially distributed out in a cylinder, tiny cylinder around the sun. And the object that's over here and the object that are over here, they're orbiting at very similar speeds. And they're just not going to meet up to form a planet. And so you might have gotten bigger rocks than you have now, but you're not going to get an entire world in there because there's not enough mass for it to gather, to clear its own orbit out.
Right, yeah. You're watching Twitch. Is there anything happening over on Twitch?
Humor.
Okay, all right. So Arjun asks, can we learn anything about the moon formation from the DART mission or the likelihood of a body having a moon?
I don't know if the DART mission is going to look at any other objects. I mean, like Dactyl was a really hard discovery to make. Finding these moons is a challenge. I honestly suspect that LSST turning stuff up is going to do a better job finding things for us.
Mm-hmm.
It will just give us that much more to do follow-up observations on.
It is kind of interesting that, I wonder, like LSST is about finding things changing, and so it probably it's going to find a bajillion, that's a very accurate number, I know, more asteroids. And it will probably find many more interesting asteroids as well, ones with moons, etc. And then you can do some studies of them. And I guess it would be interesting to see, what phase are we in the asteroid moon formation? How do they think an asteroid got a moon? Did it catch it? Did it smash it?
It depends on which paper you read. You find both. You find both things out there in the literature. I think originally they thought that they captured them, but it feels like the numerical models are starting to lean more towards things got knocked off. This is what we think of our own quasi-moon, that it may be just something that got knocked off of the actual moon. Yeah, it's a rock world out there.
Mm-hmm. But, and again, space is so big, so it's kind of amazing that these interactions do happen.
It's the fullness of time.
If you, say you went, say the sun wasn't going to expand, and you just went billions, trillions, quadrillions of years into the future, what would the solar system look like, do you think? In terms of the rocky objects, not everything, just the asteroids. Would they be ground down into little pieces? Would they be kicked out or gobbled up through interactions with Jupiter and the sun and etc.?
So we constantly have an influx of new stuff coming in. We also have the fact that things will reconnect and recoalesce, and that we know of, we don't have anything big enough to knock apart the planets, but the planets can at least have chunks thrown into space. I don't know what the dominant factor would be. It feels to me like we'd have a lot more rubble pile asteroids than we have now, and probably more asteroids with moons, but I just don't know.
Yeah, I wonder if they would just, over time, they would interact and would smash into each other and make like much more debris, or would they just get kicked into the earth, all get scooped up? But I mean, we've had 4.5 billion years, and there's still a ton of stuff out there that hasn't found its final resting place.
Yeah, I don't think things will ever all be scooped up.
Yeah.
I do think it's reasonable to expect that just like Vesta got made a bit tinier as it created its own family of asteroids, that we will see collisions that rubbleify things. Great
Rubbleify.
moons.
Sure, that's the scientific term.
It is now.
Yeah.
No, it's not. It's really not. But then there's like, we now know that on a regular basis, there's alien asteroids that come through. Who knows how many we'll eventually capture?
Yeah.
Invaders happen, whether they come from the Kuiper Belt, the Oort cloud, or beyond. And so we can replenish the inner solar system.
I do wonder about that. Like, if you could do a survey, like a proper survey of every single asteroid in the entire solar system beyond a certain size, would a large chunk of them, would some of them be interstellar in origin? They have to be.
Yeah,
right?
no, the thinking is there's probably centaurs that are interstellar in origin.
Yeah. And what could you learn if you could figure that out, that they are interstellar, about other, I mean, I think, like, if you could bring back a sample of every single asteroid in the solar system, which I know is a ridiculous idea.
Yes, but it's a lovely one to think about when we have space droids.
That would tell you a tremendous amount about just literally the formation of the Milky Way, wouldn't it?
So it gets tricky because depending on where in the solar nebula you formed, you're going to have a completely different composition. And so trying to decouple, well, these things have different compositions because they formed at different distances from the sun, from these have different compositions because they formed in solar systems that have a different metallicity, to, well, what about the objects that formed around stars in the same star forming region we formed in, but ended up in our solar system instead of their own solar system? There's so many possible permutations. It would be a hot mess and somebody's dissertation.
Yeah.
These are the things we give to graduate students to figure
Well,
out.
it'd be robots. It'd be so many samples to examine and to dismantle and stuff. But you would.
Yeah.
You
But
would,
doing an analysis of all of that.
Yeah, a meta-analysis after everybody's had a chance to examine all of their different things. That would be incredible. Like that alone, like, like, people are really excited about getting on with the space with the human exploration, the human living on other worlds part. But there's so much that's unexplored scientifically about the solar system. Even the oceans, the Earth's oceans. It's a crazy solar system that has so much to look at.
But it's awesome.
Yeah. Yeah. Feels like we're really just scratching the surface as we record this in 2021. And yet it does also feels like there's a bazillion spacecraft out there. Like there's so much exploration being done, and yet it is just a fraction of what should and could be done.
And I don't know about you, but I feel like I'm hitting that point in life where everything I learned in college is now wrong. And
well, do you mean specifically about astronomy, or just in general?
Well, a little of both. I
Yeah.
mean, it's like the basic rules of physics have all, thank goodness, stayed the same. Although dark energy, I continue to resent you. You make the maths harder. But we
Hmm.
knew it was a possibility when I was in school. We knew it was a possibility. But like the stars don't collide, the
Hmm.
black hole in the center of the Milky Way is boring and not eating anything. Just like all of these things that we said offhand, especially in public talks to assuage people that the universe was a nice, friendly place to exist. No!
Yeah.
Milky Way, its black holes happily eating, has a little tiny baby jet we just
Yeah.
discovered,
Yeah. Yeah.
and stars hit stars, and Vesta got knocked so hard it created a family of asteroids and changed its rotation.
It looks like the late heavy
Pluto's,
bombardment was
yeah,
far worse than
yeah.
previously believed.
Pluto doesn't have many craters, appears to be geologically alive with a surface that has been around for less time than bumblebees. Yeah,
Yeah.
it's
Yeah. I mean, it's funny that, I mean, maybe you just took college, you took astronomy at the wrong time, because we're always, on the one hand, struggling to think of what's significantly different as we think back over the 15 years that we've been doing Astronomy Cast. And then on the
yeah,
other hand, you watch Cosmos with Carl Sagan and giggle at all of the mild inaccuracies that are going on in the show,
yeah.
because they just didn't have the information yet. And the difference is a couple of decades. Um, yeah, it's funny. Like, even like dark matters. Like, I was having a conversation with a researcher just a couple of days ago, and he feels that WIMPs are running out of places to hide.
Yes, I agree.
That that every iteration of weakly interacting massless particles has been experimentally, observationally cornered and ruled out.
Yeah.
And the kinds of particles that could do this job are getting weirder and weirder. And you end up with other possibilities. And the one that he likes the best is axions, which are, just another,
It's a
I mean,
thing.
it's a thing, yeah. Like, we're not talking about modified gravity, but we are definitely talking about what was the largest, most mainstream theory of dark matter is just getting
Stuff.
disproven. Yeah, yeah, just point by point constraints are just coming down on what it has to be.
But the
And
fact that we
it's
find
interesting.
galaxies with so many different mass to light ratios tells us that dark matter is stuff and not modified gravity.
Oh yeah, it's a thing. It's just not necessarily a particle the way it had originally been
Yeah.
proposed. Yeah. And it's fascinating. I find it so exciting that we get to watch the back and forth and the building up of the evidence and this turning over and that being discovered and this experiment going and ruling out that. It's very much like, I'm not into sports, but I'm sure that's how people feel when they watch a sports ball game,
Yeah.
where they know the players, they know the teams, they know the history, they know the story. This, just like, can the guy kick the ball into the net, turns into this rich tapestry of story leading up to the guy kicking the ball into the net. And it's
And
kind of
then
the same
there's
thing for us with astronomy.
and then there's dark energy. And
Yeah,
and
yeah.
like I feel like a whole lot of astronomers are just taking a step back from that one and going, not my monkey.
Is it there? Yes. Do I want to talk about it? No.
No.
Yeah, yeah,
It's,
absolutely. Yeah, it is amazing that it is dominating the universe,
we
and
have no idea.
we have no idea what it is, and like, don't even have places to like, they haven't even finished measuring it yet
Yeah.
before they even get to the point where they try to figure out what's causing it. And it certainly feels definitely premature at this point to try and have any sense of what it is. And I'm sure the cosmologists are like that. They're like, yeah, just let us measure it first, please. before we try to figure out what it is.
And they argue so hard about it. Like when I was in college, the Hubble parameter was either 50 or 100. And all
Right.
of my professors were just like, use 100, it makes the math easier, for which I am so grateful.
Right. Now they have to use 60, whatever, 8 point something, right?
Right. But now they're arguing over like 3 kilometers per second per megaparsec. And how that argument comes out is going to have a lot to do with how we eventually figure out dark energy and dark matter. And
Yeah.
3 kilometers per second per megaparsec. That's what the arguments are over, basically.
Sure. But it's such an important number.
I
So
know. It's just
one,
when you put the scale on what the argument is over,
yeah.
it's just profound.
Yeah, one means you have to throw out the standard model of cosmology or deeply adapt it. You have to change the standard model of the universe, which is going to, that's going to be rough. And then the other one is either one measurement is super wrong or the other measurement is super wrong, and nobody wants to admit that they have the wrong measurement. It's it's absolutely, it is fascinating. And this is the thing, like I talk about this, like that's where I think we're at with our audience, and that's where I definitely am with the audience on the stuff that I do, is like we can skip all of the simplistic stuff and get right to the interesting advancements, that weaves the story that we're telling about the advancements and the discoveries that are being made. And it's fun. I feel grateful that we have an audience that is that up to speed, and that we can have this conversation, that we don't have to be like CNN going, what's a black hole? Right.
And this year we started off our season with filling in a request to revisit the solar system and worlds, and an area that we don't usually linger very much because I'm really much more of an astronomer.
Not a planetary scientist.
No, I just play one on the internet. But what we're looking at currently is our schedule at the moment goes out to, with any solidity, to January 21st. And then it gets into things I randomly put in there as we wait to see if JWST works or not. And just the fact that we're now looking at trying to figure out how to sort our schedule based on whether or not a telescope that should have launched about the same time our show launched actually functions. Is
if it fails, are we just gonna have episode after episode of us just sobbing? Is that how that's gonna go?
So I don't know if you read the CosmoQuest newsletter or not.
Yeah.
The last director's notes that I put at the top was we keep getting asked, are you going to live stream JWST? And I'm like, me personally, probably not, because if something goes wrong, I just want to drink. And and I ended it with a be kind to the astronomers around you, because they're living on frayed nerves.
Yeah, and they got 30 days of day after day of waiting to hear back that specific actuators are actually going to function properly. Yeah, it's going to be a stressful time. It's just getting that telescope off the ground will be a relief, but there's plenty more misery and stress coming for the next 30 days.
Yeah.
But we're 2 weeks away. Less.
Yeah. They're working
days away.
They now have it in the same building as its rocket. So they met, is how it was put in the press release I got this morning.
Yeah, I saw that too. Yeah.
I think the press officers are bored at this point.
Well, they've been giving us play-by-play, a level of detail that we don't normally get with a mission. Like sometimes they used to give us a press release when the rocket was attached or put in the fairing. You get one last picture of it before it was sent on its way. But we got news of the arrival of the booster, the upper stage, the fairing, the spacecraft, when the spacecraft was refueled, like when they fueled up the spacecraft, that just happened a couple of days ago, moving things around. Yeah, I'm again, this is the sports ball analogy. I'm loving the play-by-play, moment-by-moment updates leading to the culmination of this thing blasting off and successfully making it to space. Well, we've reached the end of our hour. Pamela, time to wrap things up. Thank you, everybody, for joining us today. Really appreciate it. John, I hope that was more astronomy dense, which I know you like. We'll be back next week for one more episode before we go on our holiday break. It's probably going to be a pretty laid back episode where we're just going to be talking about
yammer.
We're going to yammer about stuff we've been excited about, stuff we're looking forward to. I'm sure half of it will be spent on us freaking out about James Webb. But thank you everyone watching us both on YouTube and on Twitch. Thank you to all the moderators. Thank you, Nancy and Beth and Richard and everyone else Allie and everyone else who joins us. Appreciate it. We